Okay, everyone, welcome back to my channel. Today, we want to start our lesson. Sorry for the noise. There's this construction being done by my house, and they keep hammering. I think they are trying to fix the roof, so you'll be getting some form of feedback from that. Okay, but I'll try as much as possible to talk louder so that my voice can overshadow. Uh, Whatever is going on. So we are going to take some few minutes, maybe just 5 minutes to wait for people to join the stream, and then we can just quickly spring into action and then start. Okay. So without wasting time, let's just wait. So this is the time if you have to go and get water, if you have to go and get a snack or a drink, your notebook, your pen, please do so that we can start and then finish in time or on time. So quickly, our purpose for today basically is to just continue where we stopped the last time. And the last time we're trying to do a prep, running through the syllabus. Okay, we're trying to run through the syllabus. So we started and then we had to stop at some point after 1 hour. It's the same thing, we're going to do that, but today we'll try and see if we can do 1 hour 30 minutes or 2 hours. Okay, so let's just wait for some time so that the class starts. So yeah, basically that is it. As of now, I think we have just 8 people joining us. Okay, so please kindly share the link with your friends. Maybe they've forgotten that we have a class today. Okay, so share the link with your friends so that they can join us. I'm also doing that as I speak to you now. So the various groups that I know I have students in, I'm trying to paste the link in those groups, so you can also do that. Feel free to paste it in your chat group, your family group, anything, because this is basically JHS math, and then because we are going into details, some form of SHS concepts will be touched. Okay, so if you are doing that, then it basically means that anyone who is interested in math or is prepping for math exams now or in the future should be able to join us and also benefit from what exactly is going on here. Okay, so we'll be starting in the next 2 minutes. So yeah, basically today we have a lot to talk about. We have a lot of topics to go through. We also have wow. So sorry about the noise. Okay, they are doing their job. I can't go and tell them to stop. So that's the sad aspect of it. Okay, so let's just manage. Okay. So the very first one we want to talk about today will be statistics. So we want to look at statistics into details, and then we want to look at how deep we can go in terms of statistics. Now with statistics, it means I'll take my time to talk about all the aspects of the statistics, talk about pie chart, talk about mean, mode, median. I'll talk about histogram, the difference between a bar graph and a histogram. I'm going to talk about that. I'm going to talk about how to do your frequency table well, so that I don't make mistakes. I'll also talk about how to basically, let me see, yeah, talk about probability, fraction, percentage, stem and leaf plots. So we have a lot to do. So this is actually a complete revision, okay, a complete revision. Now, your assignment for this particular section will be pasted before the class ends. Now the assignment is in 2 parts and they are all related to Google Forms. Okay, So the assignment, you have up to Saturday 8 p.m. to submit, because you don't submit assignments on Sunday. And I need to give a feedback. I don't want to give feedbacks on Sunday, so I have to use from 8 p.m. till maybe 12 noon to give the feedback. Okay. So having that in mind, your assignment, you're supposed to submit it at 8 p.m. 8 p.m. Your assignment is supposed to be submitted at 8 p.m. And then, sorry, I had to adjust the mic so you can get some feedback. Sorry about that. Okay, so that's fine. So your assignment 8 p.m. I'll paste the link in the description before the class is over. Okay. And then I was about to say something, but I think I forgot it. So we'll just quickly spring into action and then discuss. So the very first thing we want to talk about is statistics. Now with statistics, there are various topics under statistics. Technically, if you are doing advanced maths, those topics are picked individually and they are treated. Okay? So statistics, basically, we are going to look at how to collect data, collection of data, how to group data, what is a group data, what is a ungroup data, what is raw data. And then we are going to look at how to represent those data in two different types of tables. The first one is frequency table, and then the second one is also a stem and leaf plot. Okay, so those are the table representations of what? Statistics. Okay, so we should look at frequency table, and then we should also look at stem and leaf plots. Okay, and then we'll also look at another data representation which is not in a table form but graphical form. Okay, and then the first graphical form we'll look at will be bar charts. Some people call it graph. Then we'll look at its similar brother, which is a histogram. Okay, then we'll also look at pie charts. Okay, so they are all charts, visual representation of data. Then we'll also look at how to calculate, central tendency. Now central tendency basically is how to calculate mean, mode, and median. That is how it is called. The mathematical name for those three are called central tendency. Now when it comes to central tendency, we have others, but for your level, you'll be narrowed to just mean, mode, median. Okay, mean, mode, median. Sometimes they add something called range, so maybe we'll look at the range. Okay, but with range, yeah, they add something called range, so we'll look at the range. Sorry about the noise. Let's just manage. We should be finishing soon, and then also we'll wrap up with whatever we have. So the very first thing, I'm going to take an example. Okay, so I'm going to change the marker color, and I'm going to take an example which will be data. Okay, which will be data. Now we want to look at the definition for data. Data is a raw fact or concept collected. So if I decide that, so all the people watching me now are actually students of Richard School and they have names, that is a fact. So if I decide to collect the names, then I'm actually gathering data from what? Richard School students. Okay, so collecting a name which is actually factual in terms of it being the person's name. When you collect them and then you collect them from a group of people, then it means you can use that as your data. So let's see if I decide to collect maybe alphabets, okay, of the teams you love or the food you love, and I end up getting T, T, M, W, T, and then S, M. We are going to use this data, so if you have your notebook, you can also go ahead and then copy it, S, and then M. This is important because this is going to help us do a proper tally, how to do a proper tally so that you don't make mistakes, so that you don't leave anything out. Okay, M, S, S, and then we have W, W, S, F, S, and then we have, so please copy the data with me so that we can quickly finish the statistics and look at other topics. So you could see the title 10 super topics. Okay, 10 super topics. So it means that we're going to discuss various topics. I'm hoping that we should be able to finish the 10 super topics, which would mean that I would have to quickly go through some of them. So those who are chatting unnecessarily on Telegram and the rest, prompt on the chat section, please beware, because I can actually put you on timeout. Let's pay attention. This is not a social place, this is a classroom. Okay, so all rights should be observed, or all rules should be observed here. Okay, so when I'm done, you should be able to tell me the number of data I have. Okay, so yes, I'm done with my data. So if you want to quickly know the number of data I have, for it to be interactive, I want to find out from the chat section the amount of data I have, so that I'll know that, okay, you can actually see all that is being written on the board. Okay, so what do you think? What amount of data do I have? So 1, 2, 3, 4, 5, 6, 7, and then we have 1, 2, 3, 4, 5. So 7, that's what, 35. Okay, awesome. So someone got it correct, 35. So quickly, we are going to look at how to draw a frequency table for this. I know most of you know this, but please just stay tuned, because I might make mention of something that you've forgotten or something you've never heard before. Okay, so stay tuned. So let's assume these are the days in the week, and they are represented basically by the first letter of the alphabet. Okay, we are not going to make differentiation between Saturday and then what, Sunday. We are not going to make any differentiation between what, Tuesday and Thursday. No. So we only need to know what it is, okay, in order to name the frequency table. So I'll name it as well days, and then I'll just use the letters to do the representation. Now please take note, if your data is actually in small letters, you write small letters. If it's in capital letters, you write capital letters. This one, they are in capital letters, so I'm going to be representing it with what, capital letters. Are we okay? So once we are done with that, now tally. So I want to explain something now. There are various ways your questions will be posed. Okay, so for this particular one, this is a raw data. It has not been grouped yet for you. Okay, so for some questions, they will actually group them, so you get something like this. So they'll say days here, and then maybe number. Okay, and then they'll do T M S T W. No, this is F actually, and then they'll put the number there, maybe 63492. Okay, so this is just an example. Now with this one, the one on the table on my left hand side, it doesn't require you to do a tally. It doesn't require you to do a tally. So when you get a table like that, which is your question, and they are supposed to make a frequency table for it to help you solve the median and then the mean, all you need to do is to just go straight ahead to put that table in the frequency table, and just ignore tally. Do not create space for tally, do not do tally. But if it is given in a raw data like this, then you have to do a tally. Okay, you have to do a tally. So basically, if it is given in a raw data like this, you do a tally. No tally for a grouped data. Okay, so this is a group data. No tally for it. Okay, so with that one, you don't have to do a tally. So with this one, we are going to do a tally, and then there's a way to do a tally to ensure that you do not make a mistake or leave any data out. Mostly students, when they are doing the tally, they will fish and then tally it. No, that you can easily make a mistake. So what you need to do is that if you have a pencil, all you need to do, you have all the data representation in the frequency table. So you go, if you want to go horizontal, fine. If you want to go vertical, that's also fine. So what you do is that if the first one I'm going to cross out is T, I'm going to tally it here. The next one, S, I'm going to tally it. So M will tally. W, I'm going to tally. Okay. So you do that. You go through that process. I'm not going to go through the whole process. I'm just going to tally them quickly. But that is what you are expected to do. Okay. So doing that, remember when you get to 4 and you want to go to 5, the 5 should cross. Okay, the 5 should cross. Okay, so 1, 2, 3, 4, and then 5, use it to cross, so to form a bundle. Okay, 1, 2, 3, and then we'll have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and then 1, and then we have 1, 2, 3, 4. Okay, so doing that, and now on this side we have frequency. So with the frequency basically will have 3, 8, 8, 11, and then what? 30. No, okay, so 4 before the 35. So the 35, how do you obtain the 35? You obtain the 35 basically by doing some form of addition. So add. Okay, that's how come we obtain the frequency, which is the final frequency. Now there's this symbol called sigma. Sigma means what? Total. So another way to represent total, we'll say sigma frequency. We don't want to write the full word frequency, so we normally represent it with what? Small f, and then with this side represent it with what? X. So it means our sigma frequency is going to be 35. Okay, so having done this, remember, if you are tallying, you tally individually. Okay, so that if maybe you are doing it and something falls and you have to shift your attention from the process, you don't lose track of what you tallied and what you have not tallied. Okay, so having this is how you do a frequency table. So we'll quickly go into details and pick a question that will require us to calculate or find the mean, the mode, and the median. Okay, a question that will require us to find the mean, mode, and then median. But before we take any question like that, what I want to talk about basically is to explain how to find a median, because I think mean, most of you do not have issues finding mean, but when it comes to median, you have an issue. For mode, you don't have an issue. Okay, so we are going to discuss those ones. So let me just create space. Let me just create space here. Okay, so the next thing we want to talk about will be mode, mean, and then median. Median is going to be the last thing we talk about, and please pay attention. The median is very, very important, because oftentimes most students they do the calculation up towards the position, but they forget to do the cumulative addition to get the answer. Okay, so it is very, very important. Now, for what is mode? Mode basically is the highest occurring, okay, the highest occurring data. Yes, the highest occurring data that we have. So let's quickly take an example, and then we are going to use that example to build and explain the mean, mode, and median. Okay, so this is the example. The following are, you can copy please, the records. Okay, records obtained by 30 JHS 2 students. So normally, if they give you the number ensure that the data that has been given matches the number. Okay, so I'm going to write the data here, and then we are all going to check and ensure that it actually does match the number. Okay, so let's see, we have 5, 3, 4, 3, 4, 3, 2, 2, 1, 4, 3, 2, 5, 4, 2, 2, 5, 3, 4, 3, 3, 3, 4, 2, 1, 3, 4, 1, 2, 3, and then I think we have an additional one. We have an additional one, but okay. Let me count quickly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 3. So this one. Okay, so I'm going to take this one out because it seems we have our 30 already. Okay, so I'll take that one out. So let me count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we have 1, 2, 3. So that makes 30. Okay. Now the first thing they say we should do, or they are saying we should do, is we should use the data to find the mode and then calculate the median. Okay. So draw a frequency. A frequency table. Then B, calculate I. So mean median, and then C, find the mode. Okay, find the mode. So let me just add D, which will be what percentage of students scored below 3. So what percentage of students scored below 3? Now this is really important. Okay, below 3, the word scored below 3 is important because it's going to determine which of the data we are actually going to use for our calculation. So I'm going to move up a bit. Okay, for the first preamble, we don't really need it. So I'm going to move up a bit to create space for us to do our tally. Okay, so quickly, let me draw a frequency table here. So let's see, we have this as our frequency table. Okay, and then I'm going to divide it into parts. Okay, so let me see if this will be okay. Awesome. So once I have that, I've done the division. The first part, since it is marks obtained, I'm going to write marks here, and then I'm going to represent it with X. Okay, so any of the description, whether mark, age, or anything, you represent it with what? X. Okay, so and then we'll have a tally. Remember I said that you do the tally if the data is not grouped. You do the tally if the data is not grouped. Now with this one, the data has not been grouped because the data given to us is not in a table form, so it means you have to do a tally. Then we have to do our frequency. And then our frequency is represented with F. Okay, so we'll put that F there. Now there's a fourth part. The fourth part is frequency being multiplied with what? Our mark. Okay, frequency being multiplied with our mark. And that basically is going to help us solve for the mean. So if you have a table that, or you have a question that does not require that you find mean, there's no need to do fx. Okay, So now let's look at it. So quickly, you go through the data to find out which is your lowest data given. The lowest is 1, and then the highest is 5. So, and then we are sure that we have 1, 2, 3, 4, 5. So you have to check that there are no missing consecutive number in it. Okay, there are no missing number in it, so that when you are writing from that range, you can easily do that. So we'll have 1, 2, 3, 4, and then what? 5. Okay, so once we have that, we'll quickly do our tally, and then remember we've already discussed how to do our tally. So doing our tally, we are saying that we are going to tally individually. How do we do that? To tally individually basically means that go take a pencil, pick the first number, cross it out, and tally it. Okay, you can go vertical any direction you want. I'll decide to go vertical now. So 3 we tally, 4 we tally, 3 again you tally it, 4 you tally, and then 3 you tally. Okay, then so this will help us. So you see, now I can stop and talk, and I'll not be confused as to which one I've tallied and which one I have not tallied. Okay, so doing that helps. Okay, so I'm not going to waste time to do all that. All I'm going to do is to tally this quickly, and then we can go ahead and then solve the rest of the questions related to this. Now please take note that when you are tallying, when you get to 4 and you want 5, you have to cross. Okay, you have to cross. Examiners check this, so it's very, very important for you, okay, to do so. So doing that, now when we quickly do that, the tally is going to help us set our frequency, so we don't have to go back and count 1, 2, 3, 4, 5 and then we tally. No, that is a wrong thing to do, because if you mistakenly leave out 1, 5, then at the end of the day you will not be getting your accurate frequency. So with this one, we are sure that our frequency for the data one is what? 3, and then we have 7, we have 10, we have 7 again, and then we have 3. Okay, so once we have this, we can quickly do our sigma. I've already explained what sigma is. So sigma, which is going to be equal to 30. Okay, now fx. Now fx basically means what? Frequency multiplied by what? Marks. Okay, so you know that the marks are actually numbers that we can use in multiplication, unlike the first example where we were doing first letters of the names of the days in a week. Okay, that one we can actually do the multiplication with the frequency, so they will not give you that type of question or data to find frequency, mode, median, and no, they will give you a data that is made up of numbers, so that you can do your multiplication and then find your frequency, find your mean, and then median. So quickly doing that, for median they can give you a data that's not related to numbers. Okay, for mode they can give you a data that's not related to numbers, but for you to calculate a central tendency, or which is what? Median, you need numbers, or you need your x to be numbers. So we are going to do our multiplication. So doing our multiplication, this is going to give us 3. Why 3? 1 times 3 gives us 3, and this will give us 14, because 2 times 7 is 14. This will give us 30, because 3 times 10 is 30, and this will give us 4, 7, that's 28, and then we have 5, 3, that's 15. Okay, so this we can confidently say sigma fx equals now when we should add all this, let me see, this should give us, I think, 90. Okay, so this is 90 and this is 30. Are we okay? 90 and 30. Now quickly we want to answer the first part of the question, which is what? Mean. Now the mean, this is the formula, this is how, or this is the symbol for mean. Okay, x with a dash on top of it. Okay, x with a dash on top of it. So that's how mean is represented. It looks like pi, but it's not pi. Pi is 2 how do I say it? Okay, I don't want to say something that will offend anyone, but pi is like this, and then mean is just an x with a dash on top of it. So that's the symbol for mean. Okay, so once we have that, sorry about that. Once we have that, we can say mean equals the formula is actually sigma. Oh, come on. Sorry, I'll have to clean this. Hey, what's happening to my throat? Sorry about that. The formula is actually fx, sigma fx over sigma f. Most students, I don't know, maybe because they are rational or they are a bit agitated, will end up doing their fx or their mean like what? Sigma f over sigma fx. Okay, if you've done that before, please in the chat section let me know. You shouldn't be embarrassed about this. Exam pressure is well acceptable, but you should know that your mean should always be more than 1. Okay, your mean should always be more than 1. So if you have fx over, no, if you have sigma f over sigma fx, it means you're going to get a fraction, and a fraction which is a proper fraction is obviously less than 1. Okay, it's obviously less than 1. Unlike probability, which we'll be talking about very soon, probability, you shouldn't get a probability which is more than 1. Okay, you should get a fraction. So there are two different things actually. So with the mean, your mean should be more than 1. And then if you have a mean that is more than 1, if you do this reciprocal thing, then at the end of the day, you'll be getting what is going on? If you do this, it means you're going to be getting, you can get a decimal, you can get a fraction, but you don't have to get a mean that will give you a proper fraction. So anytime you are solving and you get a mean that gives you a proper fraction, then it basically means that you have interchanged the symbol, okay, or the formula. So quickly, once we've established that, let's quickly do addition. We are done with the frequency table. We have the data we want to input. So we'll say 90 equals 30. Okay, and then all we need to do is quickly do some form of cancellation. So this will go here and cancel. 3 will go here, 1 and 3 will go into 90 3 times. So it means that our mean here is 3. Mean doesn't have a unit, okay? Mean doesn't have a unit, so we don't have something like 3 marks. Oh, yeah, you can have 3 marks, but we don't have something like 3 centimeters and all that, especially if you are dealing with what? Age or something. So, but because this is a word problem, we quickly have to do therefore mean mark is 3, and then you don't just do equal to 3 and then you leave it that way. It's very, very important. Marks are actually awarded to the final answer you input there. So having established this, you can quickly go ahead and do the median. Now the median is very, very important to me because most students, as I know, they make mistake when it comes to solving the median. Okay, so now with the median we have two formulas. Okay, we have this formula and then we have this. Okay, now there are two different schools of thoughts. Now the first school of thought says that if you have a frequency, okay, which is the total frequency, this one, okay, if you have that being an odd number, then you should use the two formulas here. So it's going to give you 2, so you find the middle of it, okay, you find the average of it. But if let me clean this thing that I've done here. Okay, good. So that's the first school of thought. Another school of thought says that you should use the +1 for the odd number frequency, and then you should use the n/2 for the even number frequency. Okay, so basically whichever one you use should work for you. Whichever school of thought you use should work for you. So let's quickly look at how to find it. Now before we look at how to find it, we want to find out what exactly is the meaning or the representation of n. N is actually the same as the frequency. N is the number of data present. Okay, so if you are confused about the number of data, and then with the statistics, once you get a frequency wrong, it affects everything. So in order to prevent this whole maybe you didn't do the tally well, so your frequency is wrong, what I will advise you do is that you quickly count the data, the raw data that has been given. Okay, you're even supposed to do that in the first place. Once you calculate your frequency and get your total frequency, you always need to count the raw data and then find out if the raw data matches with the frequency, because the number of data present is always the same as the number of data that has been given. Are we okay? It's always the same as the number of data that has been given. So if you count this and this is 35, and you do your frequency, total frequency, and it is 30, then you should know that you left out a number or you left out some data. And then the n in the calculation of the median is always the same as the frequency, since the frequency is the same as the number of data that has been given. So once we've established that our frequency is what, 30, all we need to do quickly is to say 30. 30 is an even number because 2 can go into it, so we'll say 30 over 2, which will mean what, 15. Now with these ones, there are positions attached to it, so these are basically just positions. Oftentimes students, what they do is that when they do this kind of calculation and they get a position, they don't proceed to the table to obtain the mark that is the median. Now take note, the frequency you obtain is not the median. The mark you obtain, the frequency is going to actually direct you to which mark is actually the median for the data that has been given. Okay, so once we get our position, what it means is that we are going to go and do some form of cumulative addition here. Okay, on the table, the frequency table, we are going to do some form of cumulative addition. So cumulative addition basically means that if I take 3 and I add 7, I'll get to a 10. Then I'll take that 10 and add it to the next frequency. Okay, so that's cumulative addition. So we remember that the position is 15. So we want a number that when we do the additions, we are going to get 15 and beyond. We should get 15 position in that number. So doing that, we'll have this plus this giving us 10. Okay, and then 10 plus 10 giving us what, 20. It means from 10 to 20 we should get a 15th position in there. So it is the frequency 10. Okay, and that frequency 10 is not our answer, it is not the median, it is actually what is going to help us link the right median, which will be what, 3, because the 10 frequency belongs to the mark 3. Okay, so it basically means that median now is going to be equal to 3, and then we'll do a statement that the median mark, the median mark equals or is 3. Okay, so we'll do that. Then the last, not the last aspect, the last but one aspect, which says that we should find the mode. Finding the mode basically means that you should look through it and find out which number or which mark has the highest frequency, or which mark did a lot of students obtain. Now when we look at it closely using the tally for the 3 mark, the mark 3 gave us what? 10. Okay, and then its frequency is also 10. Aside that, no other mark obtained more than 10. So it means that our mode, we are working for mode now, our mode will be equal to what, 3, and then we'll put a statement there that mode mark is 3. Okay, so a coincidence, all the variables or all the answers are 3, 3, 3, 3. They sometimes will do this because once they do it and they realize that the students realize they are getting 3, 3, you might think you are doing something wrong and you end up making some changes to the question. Now for the mean, please watch that aspect of the video over and over again if you have to, because that aspect, most students make mistakes with it. They either end up here by just finding the position for you, or when they get here, the frequency, they write the frequency as the median, but it is not the median. Okay, it is not the median. So basically that is it for statistics. But before we go, we want to answer what percentage of students scored let me write students. What percentage of students scored below 3? Below 3. So we want to find out, let me push up a bit. No, I'll leave the data there. So quickly, we want to find out, that's the D part. Okay. Now, we want to find out 3, below 3. How many students scored below 3? Remember, this is max. So if they say below 3, we are expecting that 3 should not be part of it because it's supposed to be below 3. And then if you score 2 and 1 and 0, we scored below what? 3. So we are going to consider those datas. We'll quickly pick the frequency of those datas, which will be what? 3 and 7. So 3 plus 7, which will give us what? 10. And then we are going to pick the total frequency, which is going to be 10 over, we will divide it and then multiply it by 100%. So this will cancel. Now we'll have 10 over 100 over 3%. And then please kindly do this fraction. You can decide to leave it this way, it's fine. That's if it's not section B, but I think I'll advise you find the real figure for that, which should be 33 point something. Okay, 33.33333. So that should be your answer for percentage of students who scored below 3. Sometimes they might do probability question that will say that choosing a student at random, what will be the probability of choosing a student that scored more than 4. So scored more than 4 means that you scored what? 5. And 5, aside 5, there's no other number higher than 5. So that would be 3, which would be the desired event over the total event. The total event is still the frequency, which will be 30. So 3 over 30, we break that down to obtain 1 over 10. Okay, 1 over 10. Remember, probability should not be more than 1. So if you calculate your probability and get 1, then it means you have a big issue. Okay, so it means you have a big issue. So basically, that is it for statistics. We are going to move quickly to some other aspects, and then basically that aspect requires us to, okay, so we didn't discuss stem and leaf plots. So let me quickly talk about stem and leaf plots. The last time we wrote an exam and I brought stem and leaf plots, some people did not get it right. Now with the stem and leaf plots, if I have this table, don't worry, my table will not be crooked. Oh, wow, sorry. So if I have this table, let me try as much as possible to see if I can draw a very straight table. So if I have this nice table, and then we have where we call the stem, and we have the leaf. Okay, we have what we call the stem, and then we have where we call the leaf. Now the stem basically it can be as you can use 3 digits, you can fix 3 digits in the stem. So let's say if I have 2, 4, 3, 2, 9, 8, 2, 5, 1, 2, 2, 0, 2, 3, 9, 2, 4, 9, 2, 5, 0, 2, 8, 8, 2, 8, 1, 2, 9, 3, 2, 6, 4, 2, 6, 9, 2, 7, 2, 2, 7, 8. And then you are saying that I should represent this data on a stem and leaf plot. Remember, it is not your typical 2 digits number. This is a 3 digits number. But how do you represent it on a form? It means that your leaf should always have just a single number. Okay, so 1 digit. Okay, 1 digit. Your leaf should always have 1 digit, but the stem can have 2 or more. Okay, can have 1 or more, sorry, can have 1 or more. So if I want to do this representation, I'm just going to simply, the lowest basically is 2, 4. So 24, so we'll have 24 followed by 25, and then we'll have 20. Okay, we have 23 somewhere, so 23 will come up here. Then we'll have 26, we have 27, we have 28, and then 29. I think my table was too small. Okay, 29. Then what you need to do once you've done that, you quickly pick 24. 24, this is 24, so this will be my leaf. So my leaf will go to, will be 3 here. Then this is what, 29, so this will be my leaf. So my leaf 29 will have 8 here. Now what students do is that they separate the leaf with a comma. No, do not do that. Please just leave a reasonable interval between the leaf. Do not separate it with a comma. The error came from some textbooks where they are trying to help differentiate, but you don't separate the leaves with a comma. So quickly, once we do that, we have, this will be what, 1. Okay, so with 1, that will be, we'll put 1 here. So you go through that, we'll put 0 here. We'll put, so you go through that and then you finish the stem and leaf plots. Basically, the reason why I even explain stem and leaf plots is to let you know that the stem can carry more than 1 digit, but the leaf should always remain single digits. Okay, thank you for listening. Now let's move to our next topic for today, which is basically geometric construction. Geometric constructions. Remember, today is basically a day set aside to give you details of 10 super topics. We might not finish all the 10 super topics today, okay, but we'll try as much as possible to advance it. Okay, so advancing it basically will mean that all the vital topics that we should be expecting in case you are writing BECE, in case you are doing WASSCE, because all the topics that I've actually taught today comes WASSCE core maths, not elective maths. Elective maths, you should be looking at parabola, functions, series and sequence, and all those things. With that one, a lesson separately. My SHS students, I saw them out separately, so that will not influence this particular. But this particular one is for high school students, junior high school students, and the rest. Okay. So quickly, we want to look at geometric construction. Now, before we look at geometric construction, I want us to talk about circle. Okay. Circle. We are going to talk about the circle, and then we are going to label the circle. We are going to add some additional parts of a circle to what you already know. So let me see if this circle will look good. Awesome. So I have this, and then I'm going to label it nicely. Let me choose a different marker to do the labeling. So this is the center. This line should be straight. Okay. So that's the center. Let me clean this and use another tool here. Okay. So oh, come on. I have to draw it again. Sorry, guys. How come I chose the eraser? Okay. So let me put. So basically, we are going to look at the labelings of a circle. Don't worry, to look. Oh. Okay. So let's try again. So someone is saying it's breaking small. Thank God it is breaking small. Okay. The country is having data issues. I'm also having data issues. We are all having data issues. So if it's breaking, but you can still manage, please manage it. That's the country we chose to live in. But currently, I heard Vodafone is having issues. So in school, Richard School, teachers are supposed to go and do some form of training, but we were not able to go because data is out. Okay. So we have this. We have that. Let me finish this quickly. We have this. And then we have that. And then I need a straight line. So I'm going to choose a straight line. and then yeah. And then yeah, so we have that, and then we have okay, so we have this. So these are basically the labeling. So we are going to label this quickly. Let me choose the red marker to do the labeling, okay? Let me choose the red marker to do the labeling. Now the very first one is the yellow, which is the circumference. Yeah, very nice circle. Thanks. You guys appreciate. That's nice. So the very first one is the circumference of the circle. So the yellow pattern, which means the circle, is called the circumference of a circle. In other words, they actually call it what? Perimeter. Okay. In some books, they'll call it perimeter. So I'm not going to put that, because if I put a label here, okay, let me just put a label there and then see. So circumference. Okay. So the yellow pattern is the circumference. Then we'll have the straight line, this line from one end to the other, called the diameter. I know some of you know this already, but you could see I've added some extra here. Remember, all this is to just help us go into detail, so that whenever the exams is presented and they want to throw us off course, we'll still have some knowledge to prove to them that we are exceptional students. So this is our diameter. Now diameter basically is from one circumference to the other circumference, passing through the center. So this is our center. So passing through the center. So any line from one side of a circumference to another side of the circumference, passing through the center, is called diameter. Why should it pass through the center before it's called diameter? Because we have another line that also touches two sides of the circumference of a circle, but does not pass through the center. So, and that is called segment. So segment, okay, also touches two sides of what? The circle, but does not pass through the center. So that's the difference between the diameter and then the segment. So now we have one that touches one side of the circumference and then touches the center of the circle, and that is called radius. That is called radius. Now with radius, let me write the radius. I think I left out one new part that I want to introduce. So let me just do the radius. Let me see if I can get a line to do that. Okay, awesome. So okay, so now with radius touches the center and then touches the circumference of the circle, but does not go all the way to another side of what? The circumference. Now quickly, you see that the segment creates some form of, the segment is actually some form of area that is embedded with a line, sorry. So and that line can actually be compared to the diameter. The diameter is not compared to the segment. The segment is the area. Okay, so let me put here area. And then the line that is compared to the diameter is called a chord. Okay? The line that is compared to the diameter, which means that the chord touches both ends of what? The circle, but does not pass through the center. Okay? It's called the chord. And the area in which the chord creates between that line, the chord, and then the circumference of the circle, this particular area, is called the segment. Okay, so that's the segment. Okay, it's called the segment. Now we can see that we have this yellow part here, and then it's actually created with a 70 degrees angle, and that sector here is called quadrant. Okay, remember I said sector because it is made up of a 90 degrees angle. It is called quadrant. Okay, quadrant. If you've been paying attention to some of the lessons, I don't know if you've done. Okay, that's for the Sky class people. So this is actually a quadrant. Okay, but we're looking at a few of those not today, but maybe later. So a quadrant, once it is called a quadrant, it's a sector, but once it's made up of an angle of 90 degrees, it is not called a sector, but it is called what, a quadrant. But it's also a type of sector. And then the sector is, how your pizza looks when you go and buy it. So a sector will be a slice of pizza you always eat. And then you realize that we have a line here. Now this line is called the normal. I'm not going into details, I'm just giving you the extra, okay, because you don't need the details. This is called the normal. And then the line, so the line cutting through the circumference of the circle is called the normal. The one touching the circumference of the circle, a bypass sort of, is called the tangent. So you realize that some of the things we say, tangent of a circle, tangent of a circle. Now the normal and the tangent are supposed to create an angle which is 90 degrees. So you realize that this angle here is 90 degrees. Okay? The normal and the tangent are supposed to create an angle which is what? 90 degrees. Okay? So basically those are the extras I was talking about. I forgot that one basically, if I decide to take a portion of what? The circumference. That curved portion is called the arc. Now the arc is spelled A-R-C, not the arc or archbishop you people think. Okay, it's called the arc and it's spelled A-R-C. So those are the parts of a circle. Okay, why would we have to learn all this? Because when you are doing, it's recently that they're taking out cone. Okay, for finding cone, but I saw some form of virtual mock for BECE 2020 where they had a calculation. They asked you to calculate for cone. Okay, so which means that calculation for cone is a possibility. It's possible that you could be quizzed on how to calculate cone. So we'll basically learn everything. I think we did the calculation for cone in Form 1 for the Richard School students. So please review your notes and just keep it at the back of your mind. It's possible that maybe they will bring that. As I said, why there are questions, they are almost out of questions. So all they do is to bring a bit of what? WASSCE questions, because WASSCE questions are just a little advanced form of BECE maths. Okay? The core math aspect is just a little advancement of BECE maths. The difference is that there are certain topics like matrices and all those things that are not included in the BECE syllabus. So it's very, very important to be all around, okay? So this is the drawing for the circle. This is the drawing for the circle. That one thing we want to take away, we need to note, nota bene, is that 2 times the radius gives us the diameter. Okay? 2 times the radius gives us what? Diameter. So let's keep in mind, okay? And then we are saying that the quadrant is an area bounded by the radial and or an arc, okay? An arc. And then the difference between the quadrant and the sector is that for sector, the angles are normally more or less than 90. So when you have a sector that the angle is what? More than 90, it is called a sector. When you have one that is less than 90, it is called a sector. But when you have a sector that is equal to 90, it is called what? A quadrant. This one. It is called a quadrant. Okay? It is called a quadrant. So let's pay close attention to that. Now, what do you think will be the definition of a circle? A circle is a plane shape or figure powered by an arc. Okay? Powered by an arc or a locus. Good. The word locus or loci, locus, okay, is singular, and then loci, oh, this is supposed to be L. I think I'm getting hungry. I'm not eating anyway. I hope you didn't hear that. Loci. Loci is a plural form, just like the way we have radius, there should be A here, and then we have radii. Okay, this is a plural form of radius. So basically, that is it. The locus is just a part around the point. We'll talk about locus because we are looking at geometric construction now. Okay, so please don't go away. The part that we are going to talk about is very, very important. We want to cover everything geometric construction. We want to cover every single thing geometric construction. So those going off, well, I can't prevent you from going off, but it's actually your own cup of tea. So we want to look at geometric construction, and some form of construction we want to look at basically will be how to do certain vital angle, how will I say it? Construction of angles. The possibility of maybe you being asked to construct 105, 120, 75. I got a question. 37.5 is possible. They can say construct an angle, or angle ABC equals 37.5. How do you construct that? We are going to be talking about that very soon. So let me just go to a new or a blank space, and once I go to the blank space, we are going to look at how to construct those angles. They are very, very important. Okay, now let's look at a typical way to bisect an angle. So I'll call it bisection of angles. There are two ways to bisect an angle. It depends on where the angle is. Is the angle in a triangle, or it is just an angle you are bisecting? If it's in a triangle, there's a way to bisect it. If it is just an angle you are bisecting, there's a way to do that bisection. Then we want to look at how to bisect a line. So we want to look at how to bisect a line. We want to look at bisection of what? An angle. And then we want to look at bisection of an angle in a triangle. So there's different ways to do this. Okay, bisection of a line, bisection of an angle, bisection of an angle in a triangle. They all have their ways of doing it. It's very, very important to pay attention to this part of the lesson, because when we meet one-on-one, I might not get the period and all those things, might not grants me permission to go deep. This is a perfect opportunity for us to cover every single thing, okay? Including things that your syllabus not require us to go into details of. We will just go into details of them, so that when YF wants to misbehave with us, we will show them that we are well prepared. So let's say, assuming we've been told that we should calculate, or we should construct, using a ruler and a pair of compasses, for you bisect the following angle. So that is the question. Bisect the following angle. Then they'll give you, oh, no. I have to choose something. Yeah, let me choose freehand. So AB equal 8. So when you have this means what? A line segment. Okay, a line segment. When you have CD and with these two bars, it means a line segment. You should by now know the difference between a line segment, a line, blah blah blah. Okay, and then when you do this also, it also means a line. But when you do this, it means what? A vector. Okay, so please, the little things in mathematics are very vital. The little things in mathematics are very, very important. So kindly pay attention to them. Okay, kindly pay attention to them. Now they are saying that we should, using the ruler and a pair of compasses only, bisect the following lines. It's supposed to be the following lines, but I'm just going to do just one. Okay, maybe we'll look at the third one. Now, how do you draw a line in the first place when you are constructing? Do not take the ruler to measure the line. So when you measure, then it basically means this will be A and this will be B. No, draw a straight line long enough to contain the measurement that I are saying you should use. Pick your compass and then stand at a point where if you should draw a semicircle, the semicircle will not be hanging like this. If it hangs like this, it is not acceptable. Okay, so it means that you should pick a point that when you decide to draw a semicircle using 1 centimeter or 1 millimeter, the semicircle, I think it's normally millimeter, the semicircle should not be hanging without a line on it. So what we want to look at, or what I'm saying basically, is if I should have maybe 8 centimeters, what I'll do is that I'll stand somewhere here, because I know that if I have my compass open this way, my semicircle is going to go from here to this side, so that it is not hanging like the way this one is hanging. Okay, so that is very, very important. Okay, so basically you give an interval that your if you should draw a semicircle on that point, it doesn't hang. Okay, it doesn't hang. Let me move up a bit. So having said that, we want to draw a line, a very straight line, and then once we draw that line, we will go inside the line, not at the tip, because we want, in case we have to draw a semicircle, we don't want the semicircle to look like this, hanging like this. No, that's not acceptable. So we'll go into the line. That's why you have to draw a line, a long one. Okay, you have to draw a long line. So if I have something like this is better. Okay, good. So let me clean that semicircle, because you are just drawing a point. So my points at, oh come on, let me draw again. Okay, so basically my points should be this line. Now with this line, I'm not going to stand at the tip, I'll stand here, and this is going to be my A. So once I have that marked, all I need to do is to pick my ruler, measure my 8 centimeters using my compass. Okay, measure my 8 centimeters using my compass. Once I measure my 8 centimeters using my compass, I ensure that the pin part of the compass stands on the line. Please don't put it in front of the line or behind the line. It should stand on the stripe that you made, which indicates what? The point. It should stand there. Okay? Oh, come, really? Okay, fine. So it should be on that line, and then you'd use your compass to do or create an arc like this. So that's going to be our B. So remember that compass was open to what? 8 centimeters using the ruler. So it means that when you stand here, all you have to do is to mark. Okay? All you have to do is to mark. Once you do the marking, then it basically means that you've drawn a line segment. Now, how do you bisect a line segment? The rule says that stand at one point open to more than half of the line. Open to more than half of the line doesn't mean you should come and stand here. This is too close to half. Okay? This is too close to half. So rather go here, but we are not going to go to the extreme of standing here. So these 2 points are actually unacceptable, but if I should stand at this point, this is reasonable. So anywhere within this range is accepted. Okay, anywhere within this range is accepted, but do not go too close to half, and do not go too close to the full length of the line. Okay, so having done that, we'll just stand here and then we'll draw. Let me clean these things up here. So having done that, all we need to do is to just stand at one point. So we'll stand at this point, and then we'll open to more than half, and then we'll draw an arc, and then we'll draw the same arc downwards using the same radius. We are not going to left, we are not going to close, we are not going to do anything. Please do not drop the compass when you do that. Ensure that you still have your compass. So what I normally do is that when I was in GHS, because I don't want to drop my compass, and I don't want to go back and measure if I drop it, I fix the handle of my compass in my mouth. Please ensure hygiene anyway. I fix the handle of my compass in my mouth, and then I do whatever I need to do with both hands or just one hand. Before, when I'm ready, I pick it up and then I do the other one. So once we've done this one first, so this is the first one. The second one, we will stand here with the same radius. That is why it is important not to drop your compass. Okay, it is important not to drop your compass. So not dropping our compass with the same radius, we are going to have this. We will stand here, and then we will draw an arc, So once we've done that, we will have one intersection up there with those arcs, another intersection up there with those arcs. All we need to do is to pick our ruler, place our ruler, and ensure that our ruler is placed in the middle. Please, this line might not be straight. Let me clean it. And ensure that what? Oh, come on, really? Okay, so, and then please ensure that your line is straight and it's passing through. What is this? So let me just do a freehand. I'm trying to, as much as possible, to get the line straight, but it's misbehaving. So I'm going to do a freehand. Okay? Ensure that your line is straight and it's passing through the intersections. It's very, very important. Now, please, when you are drawing your line, oftentimes students do this, and then they just ensure that the line ends at the intersection. Please, no, it is not acceptable in construction. So please try as much as possible that the line passes through the center of the intersections and also actually goes out, give an allowance. Okay, so that's how you bisect. Okay, that's how you bisect a line. Now we quickly remember we spoke about bisecting a line segment. We want to look at how to bisect an angle. Okay, so please stay tuned. It's very, very important to know how to bisect an angle, and then also it's very important to know how to bisect an angle in a triangle. So maybe we'll end the geometric construction at that point. We might actually end this part of the series so that the next time the super 100 questions, super 10 topics will be in parts. So remember, we did the first part, that was Tuesday. We'll do the second. We are doing the second part today, and then we might not be able to finish because I'm trying to go into details as possible. We should be able to do vectors. We should be able to do mapping, how to find the rule of a mapping. What is the mapping? We have exponential mapping, which is also called exponential ratio of mapping. How do you do the calculations for that? Where you use y equals b r raised to the power x. Okay, so we want to look at all those things. Remember, we've done the one that you use the equation of the line to do the calculation for. Okay. Okay, so someone is saying measure 6 using a compass. Is that what I said? Using a ruler, sorry. So basically, that is what we should be able to do. Now, let's assume we have this angle. And then they said we should bisect the angle. So let me name A, B, C. Okay? So having A, B, C, and they are saying you should bisect this angle. Normally, you want to bisect an angle to divide an angle into 2 equal parts. So that is what is going to help us. If you have 75, when we bisect it, we should get 30, I think so, yeah, something, 37.5. Okay, so that's how, when you have 75, you bisect it, you get 37.5. Okay, so that's how bisecting of angles is really, really important to us. So having this angle, we want to bisect this angle. Now, when you have an angle drawn like this and you want to bisect it, what you need to do is to stand at the vertex of the angle. Okay, when you stand there, open to a reasonable radius and draw an arc to cut the 2 lines that form the angle. So I've drawn an arc to cut the 2 lines that form the angle. Once you are done with that, with the same radius, you can decide to stand at the new points that have been created, which is the intersections between the lines that form the angle and the arc you've drawn. Okay, so once you do that, you stand at what? Points A and then points B in separately using the same measurement. When you stand here, you draw an arc. You come and stand here, you draw an arc, and then it will create an intersection for you. Join the intersection with the vertex of the triangle. And as usual, as I said, ensure that your line is extended. It should extend throughout the how do you call it? You should extend all the way, okay? You don't end at the intersection, okay? So basically, this is how to do the bisection of an angle. No matter the angle they give you, so assuming I'm given an angle like this, I have here to be DQP, angle DPQ, or DQP, sorry. And then they said I should bisect. All I need to do is to stand at the vertex here. Let me change the marker. Stand at the vertex here, and then draw an arc using a reasonable radius. Stand here, and then cut. Stand here, cut, and then I'll use my compass to draw through. Then I've bisected this arc. Bisecting the angle means that what it will divide it into two equal parts. So that's how you bisect an angle. But how do you bisect an angle in a triangle? Well, for some schools of thought, they will say that you should use the same method. But now what happens is that examiners are trying to make things complicated as possible. So they say that when you have, assuming you are asked to do some construction, and then your construction, this was your construction. Let me try and see if I can use a line to make, okay, I have an angle, a triangle. Good. So this was your construction basically. Okay. You've done all the fancy things. Let me see, for all the fancy things. Probably they even ask you to do some bisection. Okay. They ask you to do some bisection, which you've done, and all that. Now they are saying that let me name it A, B, C. Now they are saying that bisect angle A, B, C. So bisect angle A, B, C. Normally you won't bring this word bisect, so you can say bisect A, B, C. So this symbol here means angle. Are we okay? This symbol here means angle. So once they have that, it means that the angle, how do you indicate the angle? The letter in the middle. So you go to where the angle at that letter, which is this, okay? So I'm going to bisect this angle, okay? Now bisecting this angle, we can't say we are going to stand here, cut, stand here, cut. Yes, you can do that, okay? You can do that, but if you do that, there might be some slight error and some examiners might ignore it. But with bisecting an angle in a triangle, what you need to do is that you stand at the B and then open your compass to pass this side, okay, so the opposite side of the B, okay, a little, okay, you should just pass it a little, and then use that compass to draw an arc that will cut the line which is opposite the B, okay, that's line AC. Once it does that cutting, you realize that it gives you two different intersections. So intersection, I'll name this intersection R and then intersection S. Okay? Stand at those intersections. If you want to use the same radius, fine, but you can reduce it. Stand at those intersections, you can reduce, okay, use the same radius and create two different arcs to form an intersection, and then now you can join your vertex with it, and then it will actually accurately bisect that angle in the triangle for you. So basically that is how you bisect an angle in a triangle, okay? So let me see if I can do another example. So with another example, if I have a triangle that looks like this, okay, I've done all the fancy things. Fancy means maybe I've done all that. They asked me to bisect this, so I've done that bisection. So yeah, I've done this bisection. Let me label the angle quickly. So let's say this would be Q, P, and then what? R. And then the question says bisect. Oh. The question says bisect angle. Oh, the R is 2. What is, I'm hungry, I have to learn it. Bisect angle PQ PQR. Okay, bisect angle PQR, so that you can get some form of intersection and then you draw your line. Now bisect angle PQR, basically we have to identify the angle that gives us that, and it's always the middle letter. So you go to the angle at that letter, so that's going to be Q. So we'll stand at the vertex of Q, open our compass to a reasonable radius where the radius will pass the line that faces the angle, okay, or the line that is opposite the angle. So we're not going to go all the way to this side, no. We will go somewhere here, just pass it a little bit, okay? So we'll go somewhere here. So maybe here, your compass ends here, that's fine. If your compass ends here, then use that same radius, stand at the same vertex, which is this side, and then draw an arc. Remember, once you draw an arc from our previous example, it gives you two different intersections. Those two intersections are important because that's where you need to stand now. So I stand there using the same radius if I want. Let me clean this to make room. Using the same radius if I want, I stand there. So I'll stand here and then I'll draw an arc. I'll stand here, draw an arc. Then I'll pick my ruler and then draw a line through the intersecting arcs to the vertex. Now remember, your line is supposed to extend throughout. So basically that is how you bisect a triangle. So remember, bisecting an angle on its own is different from bisecting a triangle. If you use the old method, there will be some form of error, especially when you have this type of drawing. So when you look at it closely, this type of drawing will require that maybe you should stand here and draw a circle to touch all the vertices. That's how come some of you, when you draw your circle, you realize that P will not touch, or R will not touch, or vertex Q will not touch, because you use a different method of bisecting that particular angle. Another reason too is that they can say that you should draw this, and then this will end up being a perpendicular line, which means that it is 90 degrees, so it can be taken as the height of what? The triangle, and then they'll say maybe in a sub question that calculates the area of the triangle, which means you need to use this height, and then you do the calculation and you realize that your answer in decimal places is a bit lower or higher than the right answer. And then remember, when we are marking, we do plus 1 minus 1. So if it is a bit lower or higher and it does not fall within the range of plus 1 minus 1, plus 1 decimal place minus 1 decimal place, we need to mark the answer wrong, because we can create a large room of error. Okay, so basically, if you use the traditional one where you do the arc and then you just, let me see, the traditional one, you do the arc, you stand here, cut, and then you draw a line. This height might not be accurate, and then when you use that to do your calculation, you might get the answer wrong. So for bisecting using a triangle, please ensure that you use this method. And then for bisecting an angle in a triangle, ensure you use this method. For bisecting a normal angle, and you can use this method, and then bisecting a line, you use this method. So I think we will end here. We're not able to go much, but we were able to cover major topics. But remember, statistics, we'll have to come back to statistics, because I didn't talk about how to draw the bar graph. I didn't talk about how to draw the pie chart. I didn't talk about how to do the histogram and the difference between histogram and bar graph. So in our next meeting, we'll look at that. In our next meeting also, we'll also look at low cost, as I said here, the low cost, what it means, loci, what it means, and all that. Sometimes in your construction question, you see L1, L2. I think I taught it, but I rushed through it, so I want to take my time to explain. So please encourage your friends who are not here to be here, because what we are doing is actually important, okay? What we are doing is actually important. Please, if you not like this video, please like it, because if you don't like the video, it means you are not being fair. The more people like, the more people get access to the video, because YouTube will push the video for people to watch. People are going to write BECE, but schools are closed, and learning and having a teacher to themselves is difficult. So push the video to people as much as possible to help them, okay? This is a free service, so all you need to do is to just share the link, okay? And then please subscribe if you have not. Subscribe, okay, if you have not. So I'm quickly going to add the assignment, okay? I'm quickly going to add the assignment to the link description. Okay, so just stay tuned. You have a black screen. You will have a black screen, but once you have a black screen, don't worry about it. It's basically because I'm trying to add the assignment. So adding the assignment, I might not. What am I saying? So I'm trying to add the assignment, and I don't want you to see my desktop. Okay, so please bear with me. Okay, so let's see, and then okay, so now I think you can see some number displays and other things. Like the video, because we had more than 20 people watching. So let me paste the assignment quickly. So please stay tuned. Let me paste the assignment quickly so that you can have access to it. Do not go away. Now the assignment is in how do you call it? 3 parts. The first part is basically for you to ensure that you enter your right name and your right email address. Remember, if you enter the wrong email address, you don't get your feedback, because the feedback is sent to the email address. Some of you end up typing .con, not .com. So the email doesn't go. Some of you also add one and other things to it. You omit and all that. Okay, so ensure that you do those typings well. That's the first part. The second part basically is will give you the opportunity to we'll give you the opportunity to answer a section A. Okay, we'll give you the opportunity to answer a section A, and then we have a section B. Now in section B, there's this portion that has been created. Those who are going off are not done. They are rushing to go and answer the assignment. No one, if you go off, no one should come and tell me that you couldn't do it because you don't want to follow instructions. I'm giving the instructions and you are veering off. Go. So the section B, there's a portion that will allow you to upload the answer. Okay, please again, when you're uploading the answer, just take a snapshot of what you've calculated and uploaded. You don't have to send it to me via my email. Okay, you don't have to send it to me via my email. Please, I'm not done with my instructions, so the assignment is not pasted there. Can you take your time? By my email. Okay, so just there'll be a portion created which will give you the right to upload it directly through Google Forms. Okay, so that will be it. So let me quickly paste the assignment. Those who are rushing to get the link, I just pray you do a good job for me. So it has been pasted. Please check and ensure it is there. You have access to it. Let me know in the chat section if you have access to the assignments. Okay, let me know in the chat section if you have access to the assignment. Like the video, subscribe to the channel because we do more of this. A lot of you went off because you thought the assignment has been pasted already. Please again, instructions are more important than rushing to go and pick the questions. Okay, so instructions are more important. So the assignment is there. Thank you very much and have a nice day. Bye bye. Okay, so now I'll open it. Let me open it. Sorry about that. Okay, so it's open now. The assignment is open. so you can have access to it. So someone is saying that he or she hasn't seen the link. I think close YouTube or refresh YouTube and you should be able to see it. Okay? Close YouTube or refresh YouTube and you should be able to see it. Please subscribe to the channel if you have not done so already. Okay? Subscribe to the channel if you've not done so already. So I'm still here. If you have any issue getting access to the assignments, I'm still here. Okay.
AUX mode.
So after watching the video on the laws of indices, it is now the right time for us to apply these laws to evaluate or simplify basic indices questions that will be given to us. So indices expressions that will be given to us, we'll need to apply maybe more than one rule that we've learned. Okay, so let's stay tuned and see how best we can apply these laws. The first question basically, or the first example, will be 16 raised to the power 3 over 4. 16 raised to the power 3 over 4. So looking at this closely, we'll realize that we have a fraction which is 3 over 4. Now having this fraction 3 over 4, we can work our way around to get rid of the 4, which is the denominator of the fraction of the index. Okay, the best way to do this is to change this 16 to have a number raised to the power 4. Okay, so let's do that quickly. Now we want to look at it. 16 is equal to 2 raised to the power 4, which means that if I multiply 2 how many times? 4 times, I should get 16. Okay, so we are going to replace that 16 with what? 2 raised to the power 4. So now it becomes 2 raised to the power 4. We'll bring our bracket and then we'll bring our index fraction. Okay, now from one of the laws of indices, we stated that, please let's look on the right hand side of the board. We stated that if I have a raised to the power x or into bracket raised to the power b, then it is a raised to the power xb, because a raised to the power x times b. B will be multiplying because of this bracket. You know, in math, bracket means what? Multiplication. So it's the same principle we are going to be applying here. So let's apply that principle, which will mean that it's going to now be 2 raised to the power 4 times 3 raised to the power 4. Now looking at this expression I've written on the board, will mean that if I pick just the index and then I try as much as possible to simplify the index, I will now be having a whole number being multiplied by a fraction. And then in order to do so, if I have a whole number being multiplied by a fraction, which is 4 times what? 3 raised to the power 4. This is the same as 4 over 1 multiplied by 3 over 1. Then we can cancel diagonally because 4 can cancel 4. The numerator 4 can cancel the denominator 4. And now we'll end up having 3 raised to the power 1, which is the same as 3. So this whole index is now going to be replaced by 3. So let's just do that. So it becomes 2 raised to the power 3 because this 4 cancelled this 4 because the operation sign there was multiplication. So looking at it, our final answer will basically be equal to 8 because 2 times 2 times 2 gives us what? 8. Okay? 2 raised to the power 3 or 2 index 3 is equal to 8. Let's look at another example, which is example 2. So for example 2, we have a question which states that into bracket 1 over 81, close the bracket, raise to the power negative 1 over 4. So let's look at how best we can solve this. Now the very first thing we need to consider here is this negative sign. Okay, is this negative sign. Remember, if I have a over b raised to the power negative c, in order to get rid of this negative sign, I can basically reciprocate this fraction. What do I mean by reciprocating the fraction? It means that b over a will now remove the negative c. Okay, it will now remove the negative of the c for me. So now I'll only be having a positive c. We are going to apply the same principle to help us solve this indices. So applying that means that 81 over 1 will now be raised to the power 1 over 4. So the negative is no more there. Now that we have this, 81 over 1 is the same as 81. Okay, so now it is 81 raised to the power 1 over 4. Then we would work on removing this 4 for the index. Okay, we'll work on removing the 4 for the index. Okay, so we want to find out what raised to the power 4 will actually be equal to 81, and that is going to be 3 raised to the power 4. Okay, so 3 times 3 times 3 times 3 should give us 81. Okay, so we're going to replace that 81 with what? 3 raised to the power 4. This is to help us get rid of this denominator, which is 4. Okay, so having that, we'll now have 3 raised to the power 4 into brackets 1 raised to the power 1 over 4, which is a power. Okay, so we can quickly apply the rule that says that if I have a raised to the power m, that is in the bracket, is being raised to the power n, then it means that it is a raised to the power mn. Okay, so we are going to apply that rule, which will give us 3 raised to the power 4 times 1 over 4. Okay, now this basically is also similar to our example 1. It means that the index is what we are going to be simplifying. So we want to simplify the index. If I have 4 multiplied by 1 over 4, it means that this 4, which is the whole number, is over 1. And then I can easily cancel diagonally. So my answer here will be 1 over 1, which is the same as 1. So at the end of the day, the index form of 4 times 1 over 4 becomes 1, which will mean that now our indices will now be 3 raised to the power 1, which is the same as 3, which is our final answer. Let's look at some other examples of applying the rules or the laws of indices. The next example basically is example 3, and it is 25 over 64, all raised to the power 1 over 2. Now, power 1 over 2, or the index form of half, has its meaning. If I have x raised to the power half, it is the same as square root of x. Okay, so we'll be applying this concept in order to help us solve this. There are two ways to solve this. Okay, the first way is applying the law which says that if I have a fraction, or I have terms in an expression, and that term has been raised to a power, all those terms have been raised to a power, then it basically means that it affects it. Let me write that concept on the right hand side of the board. So it means if I have x over y, all raised to the power n, this basically means that it's going to be x raised to the power n over what? Y raised to the power n. So that's the concept we are going to be applying here. That's going to be our first way of solving this particular question. So in so doing, we will have 25 raised to the power half, all divided by 64 raised to the power half. Okay, so having that, let's just write the 25 raised to the power half, which is the same as root of 25, and then we'll have root of 64. Now, root of 25, since 25 is a perfect square, it means that root of 25 will basically mean we are looking for a number that will multiply itself to give us 25, and we all know that number is 5. And then for 65 also being a perfect square, it means that we are looking for a number that will multiply itself to give us 65, and that number is what? 8. So this will be our final answer, which is 5 out of 8, or 5 over 8. Another way to solve this, okay, which I'll name second method, basically is to change the 25 and the 64. Okay, so I have half, and then I'll change it, so 25 will be 25 raised to the power 2 over 64. 64 now being, let me clean this quickly, 64 now being 8 raised to the power 2, okay, all raised to the power half. Okay, applying this rule will mean that we'll have 5 raised to the power 2 multiplied by 1 over 2, and then we will have 8 raised to the power 2 multiplied by 1 over 2. From the examples we solved before this means that this 2 can cancel this 2, and then this 2 can also cancel this 2. This gives us the answer 5 raised to the power 1 over 8 raised to the power 1, which is the same as 5 over what? 8. So you realize that this method gives you the same answer. So whichever method you are comfortable with, you can use that method. Let's look at our last example before I bring the curtains down to this particular lesson, and that will be example 4. Okay, so with example 4, we have 25 into bracket raised to the power 1 whole number 1 over 2. Okay, so here's the case. We have an index form. This is actually a mixed fraction. So the first thing we are going to do is to work on the mixed fraction. So I'm going to write on the right hand side of the board 1 over 2. Okay, this means that the denominator is going to multiply the whole number. The answer we get, we add it to what? The numerator, which then ends up giving us 3 over 2, because 2 times 1 will give us 2 plus 1, which is 3, but we maintain the denominator as 2. So we are going to replace the 1 whole number 1 over 2 with what? 3 over 2. It is the same value, the value has not changed, so we'll have 3 over 2. In solving this, we will concentrate on trying to get rid of the denominator of the index. Okay, so this index denominator should be removed. Okay, so removing that index denominator, we would have to concentrate on how the 25 is going to help us remove that. Okay, 25 is a perfect square, which means that a number multiplying itself should give us 25, and that number is 5. So 5 raised to the power 2 should be equal to 25. Therefore, we are going to replace 5 raised to the power 2 with what? 25, and then we'll bring our index. Okay, now looking at it closely, we are going to apply one rule of indices, which says that if I have a raised to the power m and is into bracket raised to the power n, then it now becomes what? mn. Okay, so the same rule will apply here, which is going to be 2 and then times 3 raised to the power 2. Now we can go ahead and do some form of cancellation to get rid of this denominator, and then our answer will now be 5 raised to the power 3, and then 5 raised to the power 3 basically means 5 times 5 times 5, which is 25 times 5, which ends up giving us 125 as our final answer. Thank you very much for watching this lesson. Please stay tuned for more videos. The next lesson we should talk about equations involving indices. Please share, like, comment, and subscribe to the channel for more free lessons. Have a nice day. Bye bye. Father. Back to my channel today. If you want to understand the laws of indices in less than 10 minutes, this is the video for you. Stay tuned. Welcome back. So the very first law of indices, okay, basically says that if I have a raised to the power m, or index m, or exponent m, whichever way you want to say it is acceptable, and then I have multiplied by a raised to the power n, it basically means that a is going to be raised to the power n plus n. Let me explain this quickly. Now, with indices, we have what we call the base number. So, assuming I have an indices like this, this is a base number. And then this is the index. The plural form of index is indices. Okay, so the plural form of index is indices. Now we've established this. Now let's go into details and understand what exactly it means. Now, when the base numbers are the same, the law says that when the base numbers are the same and you have an operation between them, and that operation happens to be multiplication, then the powers should add. Okay, so this is the first law of indices. Let's take a question. So a question may be, example 1 will be in the form of 2 raised to the power 4 times 2 raised to the power 6, which will mean that we'll have 2 raised to the power 4 plus 6. Why? This is so because the operation sign between the base numbers, which are the same, which is 2, is multiplication. Therefore, the powers should add. This is the very first law of indices. Now let's move to the second law of indices. The second law of indices. Second law of indices. The second law says that, which is also similar to the first law, says that if I have a raised to the power m divided by a raised to the power n, then that should be simplified, or that can be simplified to give me a raised to the power m minus n. So looking at it closely, we already understand what the base number is. So in here, you realize that you have a being your base number, which is equal. Now, a being your base number, which is equal, we have to take a look at the operation between the two base numbers, and that is division. So it simply means that when you have the base numbers equal and you have an operation such as division between them, then your powers should subtract. So the first one, you have multiplication as the operation sign between the base numbers, the same base numbers, the powers add. The second one, you have division as the operation between your base numbers, then the powers should subtract. Let's quickly take an example so that we can move to the next law. So example for this will be 3 raised to the power 3 divided by 3 raised to the power 4, which will mean that we will now have 3 raised to the power 3 minus 4, and this should give us 3 raised to the power negative 1. There is a rule for this and how to write this if you don't want to leave it in an index form. Okay, so we'll be looking at that rule very soon, so stay tuned. Now we want to quickly move to example 2 of the second law of indices. Example 2 of the second law of indices. Let's see, if I have 5 raised to the power 2 over 5 raised to the power 4. Now the fraction bar is the same as this division symbol. Fraction means dividing something, okay? So, and comparing it to a whole number. So this fraction bar is the same, so it will be considered, or the solution to this 5 raised to the power 2 over 5 raised to the power 4 will be the same as writing it as 5 raised to the power 2 divided by, okay, the fraction bar is the same as division, so 5 raised to the power 4, which will mean that 5, since it's 5, that's the base number, and they are the same, and the operation between them is division, then it becomes 2 minus 4, which will end up giving us negative 2. So we'll look into this shortly, okay? So please stay tuned. Let's quickly move to the third law. Let's quickly move to the third law. Now the third law says that if I have a raised to the power m, and this is in a bracket, raised to the power n, it basically means that brackets, we already know in math, means multiplication, so the powers or the index would multiply, okay? The index would multiply, okay, which is the same as a raised to the power m n. Okay, let's take an example. If I have 3 raised to the power 4 all into bracket raised to the power 2, this basically means that it's going to be 3 raised to the power 4 times 2, which should give me 3 raised to the power 4
3 raised to the power 8. Okay, so that will be my answer. That will be my answer. So that is the third law. Let me write it here. Sorry, I left that out. So third law of indices. Okay, the third law of indices. Let's quickly look at the fourth law. That other laws aside this first three laws. Let's quickly look into those laws. So the fourth law, which I call the negative indices. The negative indices basically explains that if I have a raised to the power 2 over a raised to the power 3, we did some examples earlier, it is the same as having a divided, okay, so a raised to the power 2 divided by a raised to the power 3, which then if you are applying the second law of indices, will mean that this will be a raised to the power 2 minus 3, which should give us a raised to the power negative 1. Now, the second law basically says that if you have something like this, then this could be written as 1 over a raised to the power 1. Let's explain this. Explaining this, if I want to write this in a normal sense, where we know a raised to the power 2 means a times a, and then I have a raised to the power 3 meaning a times what? A. And I decide to do some form of cancellation. This will cancel this, and this will cancel this. We realize that we are left with just 1a. And then there's a division sign here, so obviously we'll have 1 at the top. So this will mean that we'll have 1 over a. And a is the same as 1 a over 1, a raised to the power 1. Okay, so this will be our final answer, which is similar to what we have here. Okay, so basically this solution is similar to this. What are they trying to say? Let's take an example one. Example one, if I have 6 raised to the power 7 divided by 6 raised to the power 9, you realize that I'll have 6 from the second law. I have 6 raised to the power 7 minus 9, and this should give me 6 raised to the power negative 2. Okay, this should be written as, once the power is a negative, it means you can rewrite this whole thing in a fraction form. Writing it will mean that we'll have 1 over 6 raised to the power 2. So the law of indices, which will be the fifth law of indices, which I call the zero index. The zero index. Now with the zero index, if I have a raised to the power 2 times a raised to the power 0, what this means is that it's going to be, if I'm to follow the first law of indices, it's going to be a raised to the power 2 plus 0. This should give me a raised to the power 2. Okay, now considering what else can I do to get a raised to the power 2? If I have a raised to the power 2 times 1, it should give me a raised to the power 2. Comparing this to, it basically means that a raised to the power 0 is equal to 1. Therefore, when you have any number that is raised to the power 0, is equal to 1. If I have 100 raised to the power 0, it is equal to 1. If I have 79 raised to the power 0, it is equal to 1. That is the fifth law of indices. That is the fifth law of indices. Let's go to the sixth law of indices. Let's go to the sixth law of indices. So the sixth law basically is a one which says that if I should have into bracket, let me take a brighter marker. If I should have into bracket AB raised to the power n, this n should affect all the terms in the bracket. Okay, so affecting it will basically mean that a will be raised to the power n, and then b will also be raised to the power n. Okay, and then also if I have a over b all raised to the power n, it's the same principle. The n or the index should affect the a and it should also affect the b. Okay, let's take some examples. If I have 3 over 4 raised to the power 2, this should mean that I have 3 raised to the power 2 over 4 raised to the power 2. Okay, solving this would mean I have 9 and then I have 16. Then if you want to reduce it to its simplest form, you can quickly or easily do that. Okay, so these are basically the laws of indices. Stay tuned for the next topic, which is going to be about equations involving indices.